All right, in our last section in Chapter 6, we're going to look at using the normal distribution to compare two groups. And we're going to focus on why this comparing averages of groups is a powerful concept. Now, we know not everything has the same average and standard deviation, and we're going to use those things to understand differences between groups. Now, this is going to be especially prevalent at high values, and so that's what we're going to sort of focus on. This is especially prevalent, I should say, at high values and low values. We're going to focus on the high values in the next two slides. So this is why, again, this is one of the reasons why we study averages and standard deviations of groups. So, according to the Centers for Disease Control, if you look at the average height of black adult males in the United States, it is 69.5 inches, and they have a standard deviation of 2.4 inches. Whereas, according to the same study, the average height of Asian adult males is 67.0 inches with a standard deviation of 2.2 inches. You can see the source there if you'd like to check on that. And I'm using the same language that that source uses. So if you're interested. So let's take a look. We see that these two groups have different average heights. Now the standard deviation is close, although it is a slightly different between the two groups. But they have different average heights. So the average height of black adult males is about 2.5 inches higher than the average height of Asian adult males. So let's see how that plays out with some real data and looking at the proportion of in each group of males over 76 inches tall. All right, so we're going to start with the average height of the black adult male group, and we're going to start with that group. Now we're going to assume that the heights are normally distributed, which in a lot of cases they are. I don't know for sure, but we're going to assume so in this example. So if we want to find the proportion of black adult males over 76 inches, well, that just goes back to the normal CDF function that we had before. So proportion of black adult males over 76 inches. How I would do that is I'd say, well, proportion of values greater than 76 inches. So we're going to use that normal CDF function. And our inputs, well, if I'm looking for over 76 inches, 76 is going to be my minimum bound. My upper bound is going to be some really big number. Now, in terms of inches and people's heights, you can imagine that 100,000 is a way bigger number than we actually need. But that's it. So over 76 inches is 76 up to a really big number. Type in the average 69.5 for this group, and for this group 2.4 inches is the standard deviation. So again, don't forget where that is on your calculator in the distribution menu, normal CDF 76, comma, a really big number, comma, average of 69.5 and 2.4 as the standard deviation. And what you see is that for black adult males, the proportion is extremely low for being above 76 inches tall. Okay? Now, by the way, 76 inches, I chose that number because that's about 6'4". So that's an extremely tall person in the general public. It's not so large that it can't happen, though. But it is, again, fairly a fairly large person in the general public. So what we see is about 0.34% of that group is above 76 inches tall, is above 6'4". Now, what this means that if we had a random sample of 10,000 black adult males, what would the expected value be? How many should we expect to be over 76 inches tall? Well, the expected value, if we picked 10,000, the expected value of people who are over 76 inches tall would just be what we get by taking 10,000 times the probability of being over 6'4", over 76 inches tall. And the reason I chose 10,000 is because when we multiply that, we move the decimal place over 4 spots. And so basically we'd see that in a group of 10,000 black adult males, about 34 of them we would expect to be over 76 inches tall. So I would consider that extremely tall. Now, how about Asian adult males? So because Asians have a different mean and a different standard deviation, well, that's going to change the probability of finding tall people from that group. So the probability of being over 6'4" if you're an Asian, now again, these are terms used by the CDC. They use Asians, they're meaning Asian adult males within the United States. Again, probability of being over 76 inches. So we're going to go 76 is our minimum number, our big number, and then comma. Well, Asians have a 67-inch average and a 2.2 standard deviation. So if we type that in, and I have not typed this in yet, so I'm typing it in right now. What we end up with is an extremely small number. We get a scientific notation number, 2.15 times 10 to the, now let me write that down, times 10 to the negative fifth. Now, if you found an expected value of that, multiply that number by 10,000. So just on your calculators, put times 10,000. What you'll find is that the expected, if we had a sample of 10,000 Asian adult males, the expected value would be about 0.215. All right, so less than a person. Hopefully that makes sense. If I take this, again, this number here, and multiply it times 10,000, I end up with 0.215. All right, so that is the expected value. So here's the deal. If we have a group of 10,000 black adult males, and if we have a group of 10,000 Asian adult males, we expect to find a pretty good number, 34, of the black adult males who are over 6'4" inches. And we find basically nobody from the Asian adult males who are over 6'4" inches. Okay? And by the way, this may have ramifications in lots of different scenarios, meaning like, well, there are certain things in our society which it's really beneficial to be tall. Okay, so if you're playing volleyball or if you're playing basketball, or if you're playing obviously professional sports, a lot of professional sports, it's beneficial to be tall. And so in basketball would probably be the most prominent example. And so we would see that, oh yeah, in basketball, are it you're going to find, since you find more tall black adult males than you find Asian adult males, you might see black adult males be more represented in basketball, like the NBA, than you see in Asian adult males. Okay, now this isn't a complete story of that. Don't get me wrong. There's all kinds of other factors that go into it, but this may be one factor that goes into something like that. Okay, so there you go. Sorry, I wanted to put that all on the same slide. So this is kind of the thing of why we look at averages and why we compare group averages, is because while the averages may be fairly close, and we all could imagine that there are black adult males and Asian adult males where the Asian adult male is taller than the black adult male, or vice versa, right? So we're not saying, again, we're not saying all from this group versus all from that group. But knowing that the average height is 2.5 inches more, well, it makes one group very much overrepresented in terms of really tall people, and another group underrepresented in terms of really tall people. So there you go. By the way, you could do that for lots of different groups. If you go back to the CDC, you could look up all the different groups that they lay out or that they categorize. Okay, so that's the sort of ramifications for this, that you're going to find more extremely tall black adult males than Asian adult males. And what aren't the ramifications? Well, we're not saying, again, this is a repeat of about the, I don't know, 15th time I've said it. We're not saying that all Asian adult males are going to be shorter than all black adult males. We're saying, again, the ramifications for the averages being different. So the ramifications is you're going to find more tall black adult males than Asian adult males. All right, but that doesn't mean everyone from the black adult male category is tall, right? That's the basics of it. Here's another situation that we can look at. And again, I'm trying to, once again, talk through things like I said at the end of chapter 1. This is a repeat over and over and over again. We can look at the differences between two groups and not be racist, right? We're not saying that all people from this group or all people from that group. We're saying that on average, and that difference in average makes a difference in terms of number of people that you're going to see at the very high end. Okay. All right, so in 2001, there was a gigantic study that was done on the 5-factor model traits. Now, those are like psychological traits. One of those traits, one of the 5-factor model traits, is something called agreeableness. Okay, you can look them up, all of them, if you want to. There's the source underneath. But basically, this 5-factor model trait showed that if men average a 50 on a test of agreeableness, then women would score an average of 55.9 on the same test. The standard deviation for both groups would be 10. Now, I scaled this. So if you actually look at the article, they talk about different size standard deviations and different size averages. So what I did is I just scaled this so that it makes sense in terms of a normal curve. So if men score an average of 50, women score an average of 55.9, both groups have a standard deviation of 10. So let's see what this means at the really high values. Okay, what is the probability that a randomly picked male will score above 78? Now again, above 78 is a pretty rare test on an agreeableness score in terms of my scaling. So probability that a randomly picked male will score above 78. What's the probability that a randomly picked female will score above 78? And then list out, well, what are the ramifications for this? And what aren't the ramifications? Think about it in a group of size 10,000, okay? So, I'm trying to think of what slide to land on. What I'd like you to do is push pause on the video and find the probability that a randomly picked male will score above 78 and a randomly picked female will score above 78 on an agreeableness test. All right, hopefully you went ahead and did that. When you type this in, probability that a randomly picked male will score above 78, well, basically, we're going to do a very similar thing that we did here. Instead of 76, now I have 78. So we're saying, what is the probability that randomly picked male scores above 78? So we go 78 to a really high number. The average for males is, we said, 50 with a standard deviation of 10. And so if we go ahead and calculate that on our calculator, what we do is we find that that becomes a 0.0025. Actually, I'm sorry, 0.0026 rounded to 4 decimal places. So you have about a 0.26 chance, 0.26% chance that a randomly picked male scores above 78. So think about it this way. In a group of 10,000, you would expect about 26 males to score that high, right? Again, multiply 0.0026 by 10,000, you would expect about 26 males to score that high, all right? Well, what if we did the same calculation for females? So if we did the same calculation for females, not a whole lot's changing. Probability that a randomly picked female scores above 78. So normal CDF, 78, really big number. Here we have 55.9, and 10 is still our standard deviation. Sorry, 55.9 is the average, and 10 is the standard deviation. And what you'll find is that probability comes out to 0.0136. So in a group of 10,000, you would expect about 136 females to score above a 78. Now think about that. Notice the gigantic difference in numbers of people who would score above a 78. So a small difference in our average at the very end means a big difference in the number of people in each group who score really high. Again, this is a really important concept that most people don't understand. that a small difference in average means we're going to find a lot more people at the high end, given that they have the same standard deviations. Now, we could adjust the standard deviations so it doesn't work. There's all kinds of ways we can massage this. We can give bigger standard deviations to one group and smaller to the other. We can do all kinds of weird things. But the point is, we see about a little over 5 times as many females score high on the agreeableness score. Okay? Now, what are the ramifications for this? Well, think about this in terms of maybe jobs. Okay? Well, in jobs where agreeableness is a trait that they're looking for, you might see more females in those jobs. And by the way, on the other end of the spectrum, in disagreeableness, you'd find the opposite. You'd find more disagreeable males, like that score really high on disagreeableness. So in jobs where disagreeableness is a trait that they're looking for, you might find more males. All right. Now, again, this is not 100%. What I'm saying here is generalizations. Obviously, in every job, there's lots of other factors to look for, but this may be one factor. So in terms of jobs where you need to be very agreeable, you might find more females. In jobs where you need to be disagreeable, you might find more males. Who knows? All right. Again, I'm being very simplistic and avoiding giving examples of jobs on purpose because there's so many factors to each job, and there's so many disagreeableness and agreeableness is not the only factor for any job, but again, I'm making broad generalizations here. Okay. Now, again, what aren't the ramifications for this? This does not mean that if a job requires disagreeableness, that females can't do it. This does not mean that if a job requires agreeableness, that males can't do it, right? So we shouldn't oversimplify. That would be kind of, like we said in previous sections, oversimplifying this makes us look really dumb, right? If we said, well, therefore no males can do any jobs that require agreeableness, that would be silly. There are going to be males who can do those jobs. And if we said, well, there's no females who would take on a job with disagreeableness, well, that's just silly as well. We would find females who are very disagreeable, and we would find males who are very agreeable. But my point is, you might not see the same numbers in both jobs. So if you have a disagreeable job, you might find more males, you might find more females in the agreeable job, but you should find some representation from both. But so, in other words, this is not saying that males can't do certain jobs. They clearly can. And the same goes for females. This is not to say females can't do certain jobs. They clearly can. We just might see different proportions in different various jobs. And again, that's just one factor. There's probably lots and lots of other factors that go into that. So I don't want to oversimplify, but I am oversimplifying. All right. So that's the 6.2 that I wanted to show you. Again, I'm using gender differences here precisely because it is a situation that people get a little bit nervous about. I used, the racial categories from the CDC because it's something people often get a little bit nervous about using. And the point is trying to use things that if used correctly, we shouldn't have any fear about looking and comparing two groups. Again, if used incorrectly, you could come up with some really dumb racist arguments or really bad ideas. So use these things correctly, don't use them incorrectly. Okay? But it does show us that, you know, certain changes and averages in a group make a difference for those high values, given that they have the same, given that groups have roughly the same standard deviation. So that is the end of chapter 6, and we will be moving on to chapter 7 in the next videos.